Hi students, today we are going to continue with your topic dual nature of radiation and matter. In last lecture we have discussed about some introduction about this topic and the photoelectric effect, in which what is photoelectric effect? Phenomenon of emission of electrons from metal surface when a radiation of appropriate frequency is incident on it. As you can see in the diagram, if UV radiations are incident on metal surface and that surface emit or eject electrons, right? So we have studied experimental setup of photoelectric effect, in which we have considered emitter, collector, then a circuit, that is emitter is cathode, collector is anode, and depending on that we have studied experimental setup of photoelectric effect. Now in today's lecture we are going to see observations which is observed from the experiment of photoelectric effect, that is observations from experiments on photoelectric effect. This point we are going to study today. Before that I am going to give some recall about experimental setup of photoelectric effect. As you can see in the diagram, there is a one glass tube, that is you can say evacuated glass tube, having a window, or you can say quartz window. From that window light is coming into the tube. Okay, E is what? Photosensitive material and emitter as well as cathode. C is what? Anode, or you can say another metal plate, and which is collector. Now you, as I have told you, emitter is cathode and collector is anode. So emitter is connected to the negative and collector is connected to the positive potential of the external source. Now ammeter and voltmeter is connected in the circuit. Ammeter to measure the current and voltmeter to measure the potential difference between collector and emitter. As potential difference between emitter and collector we can vary. Okay, that is C can be anode, that is collector can be anode or cathode with respect to emitter. Okay, when collector is cathode, it accelerates electron which are coming out from the emitter, and this potential on C is called as accelerating potential. And if collector is having negative potential, it will retard the flow of electron which are coming out from the emitter. Hence the negative potential on collector is called as retarding potential. Now you can see in the diagram, C is what? Monochromatic source of light which is having some sufficient frequency that we are going to use in this photoelectric effect. Metal plate E eject electrons when light is made to incident on or fall on it. When light is fall on emitter, it will eject or emit electrons, and these electrons which are emitted or ejected by emitter is called as photoelectrons, and these photoelectrons are collected by collector. So this is all about experimental setup of photoelectric effect. Now we are going to discuss observations which are observed by the scientists who have done the experiment on photoelectric effect, and they observed the things in which first is what photocurrent I was observed only if the frequency of incident radiation was more than some threshold frequency V nu 0. Nu is the same for given metal and was different for different metals used as the emitter. For given frequency, nu is greater than nu 0 of the incident radiation, electrons were always emitted even if intensity of incident radiation is less. So what is first observation is that here what we have in this experimental setup, we have chosen a source. Which source? A monochromatic source of light of sufficiently high frequency. So if frequency of incident light is less, then there will not be any emission of electrons from the emitter or from the metal plate E. Then when it will emit electrons? When the frequency of incident radiation is greater than some frequency, you can say nu 0. Means in this circuit, when emitter emits electron, collector will collect it, and you can see the current flows in the circuit, and that current is measured in ammeter. If frequency of light which is incident on emitter plate is less, there will not be any ejection of or emission of photon from emitter, sorry, electron from emitter. If electrons are not emitted, they will not go to the collector and there will not be any current. So frequency of incident source or incident radiation should be have some value, that is called as threshold frequency. If frequency of source or radiation is less than this frequency, then there will not be any emission or ejection of electron, there will not be any photocurrent, so there will not be any photoelectric effect. So we have to choose a source which emits a radiation with some frequency, that is called as threshold frequency. Okay, and V0, that is threshold frequency, is the same for given metal. If you changed the metal, threshold frequency also changes. The threshold frequency of radiation for one metal is constant, but not for all. If you change the metal, threshold frequency will vary and was different for different metals used as the emitter. That is what I have told you. For given frequency, that is, if nu is greater than nu 0 of the incident radiation, that is what I have told you. If frequency of incident radiation is more than threshold frequency, then electrons were always emitted even if intensity of incident radiations is less. Means there is a no condition for intensity should be less or minimum b hoga, then there will be the emission of electron, but there is a condition for frequency. For particular matter there should be a particular frequency, that is called as threshold frequency. Below threshold frequency there will not be any emission of electron and no photo current. So frequency of incident radiation is always greater than the threshold frequency. Then and then only metal will emit or eject electrons even if intensity of incident radiation is less. Okay, the second observation is that no time lag between the incidence of light and emission of electrons. The photocurrent started instantaneously as the incident radiation was stopped. The flow of current stopped. Means if you switch on this source and light is fall or radiations are fall on emitter plate, then immediately at that instant only what will happen? You can see the current in the or emission of electrons as well as photocurrent in your emitter. Means there will not be any time gap. Means if you have switch on the source, light is fall on the metal and after some time you will get emission of electrons. This will not happen. When light is fall on metal, at that instant only, at that instant electrons are going to emit from the metal surface. There will not be any time lag between इंसिडेंट लाइट एंड इमिशन ऑफ इलेक्ट्रॉन. मतलब लाइट इंसिडेंट होगी, उसी टाइम पे इलेक्ट्रॉन मेटल प्लेट से क्या होंगे, इमिट होंगी. एंड व्हेन यू स्टॉप और व्हेन यू स्विच ऑफ द सोर्स, photo current will or flow of current will stop immediately. Okay. Then third observation is keeping the frequency nu of incident radiation and accelerating potential V fixed, the intensity was increased. The photocurrent increased linearly with intensity. So what you have did, you have took or you have chosen one constant frequency for incident radiation along with potential, that is collector potential. जो भी potential होगा C plate पे, that will be again constant. So what will happen, and if we increased the intensity of the incident radiation, then what will happen? Electric, that is photoelectric current, increases linearly with intensity, keeping frequency nu of the incident radiation and accelerating potential V fixed, and intensity was increased, the photocurrent increased linearly with intensity. As you can see in the figure, if there is a increment in the intensity of incident light, by keeping frequency and potential of collector constant, photoelectric current increases linearly with respect to intensity of incident light. Okay, so next observation is that photocurrent I can also be varied by changing the potential of the collector plate, that it is I, that is current, was dependent on accelerating potential V for given incident radiation. Initially, the current increased with voltage, but then it remained constant, called saturation current I0. Now what we have did, photo current, if we have changed the potential on C, तो आपने क्या किया, potential on C we have increased, then what will happen, that accelerating, that is the current I was dependent on accelerating potential V for given incident radiation. Initially क्या होगा, when you increase the potential on collector plate, photocurrent increases with voltage, but after that it will remain constant, and that is called as saturation current I0. As you can see in the figure, this is accelerating potential, retarding potential. Okay, if you increase the collector potential, that is potential on collector plate, what will happen? Initially there will be the increment in the photocurrent, but after that there will not be any change in the current, that current is constant, as आपने कितना भी क्या किया, potential on collector plate C increase किया, but there will not be change in the current, that is photocurrent. So that current is called as saturation current. Okay, so next observation is keeping the accelerating voltage and incident frequency fixed and intensity of incident radiation was increased, the value of saturation current also increased proportionally. So this time accelerating voltage, that is potential on collector plate, and incident frequency of radiation is fixed, and if there is an increment in the intensity of incident radiation, then what will happen, value of saturation current also increases proportionally. Okay, तो first observation में क्या था, we have increased the potential on collector plate and intensity. So what will happen, there will be the increment in photocurrent, but after some time photocurrent will be constant, which is called as saturation current. So value of this saturation current you can change by keeping accelerating voltage on collector plate and incident frequency of incident radiation constant and intensity of radiation if you increase. So what will happen? There will be the increment in the saturation current. So next point is maximum kinetic energy, that is Ke max of electrons depended on the potential V for a given metal used for the emitter plate and for frequency of incident radiation. So what is maximum if this emitter plate emits electrons and they are moving towards the collector plate C. Okay, so if they are moving, they are having velocity, along with that you can say kinetic energy. So kinetic energy of electrons or emitted electrons from emitter plate and when they are traveling towards the collector plate, so they will have some kinetic energy, and this kinetic energy, that is maximum kinetic energy of the electrons, that is photoelectrons, depend on potential V, that is potential on collector plate V for given metal used for the emitter plate and for the frequency of incident radiation. So maximum kinetic energy of electrons depends on potential V. Okay, this is not about kinetic energy of electrons which are moving from emitter plate to collector plate. This is kinetic energy of electrons which are getting eject or emit from the metal surface. So with which speed this electrons will come out from the emitter plate will depend on maximum kinetic energy, depends on the potential V which is provided to the emitter plate, metal which we have used as a emitter plate, and frequency, incident frequency of radiation. Okay, so sixth point you cannot see on this screen, but I am going to discuss this point, that is, if increasingly negative potentials were applied to the collector, the photocurrent decreased, and for some typical value of minus V0, that is applied minus potential to collector plate C, photocurrent becomes 0, and this V0, that is minus V0, is called as cutoff or stopping potential. As you can see in the graph also, if accelerating potential and retarding potential, these potentials are for the collector plate. As I have told you in the introduction, that is in the experimental setup, we can change the potential on C, that is C can be anode, C can be cathode with respect to emitter plate. If C is anode, then it accelerates the electron, and if C is cathode, it deaccelerate or retard the electrons. Then if we have provided C with negative potential, that is collector, we have made it as a negative potential, then what will happen? और आप क्या कर रहे हो? We are gradually increasing the negative potential on collector. That is, if increasingly negative potential were applied to the collector, then photocurrent will get decreased up to some typical value of minus V0, as you can see in the graph. And this minus V0 or V0 is called as cutoff or stopping potential. Why this will happen? It is because if C is negative and electrons which are emitted from the collector plate, both are having negatively charged, then both will repel each other and it will not reach to the collector. So you will get the zero current or zero photocurrent. Okay, and that is the photocurrent becomes zero. The value of photocurrent becomes zero at minus V0 potential, and this potential is called as cutoff or stopping potential. So next point is, if the frequency of incident radiation was changed, keeping the intensity and accelerating potential V constant, then saturation current remained the same but the stopping potential changed. Now you can see in the graph on your left what we have did. We have increased the frequency of incident radiation and we have kept intensity and accelerating potential, that is potential on collector plate C, constant. So what will happen? Saturation current will be same but stopping potential V0 is changed due to increase in frequency of incident radiation. Now next point is the photocurrent, and hence the number of electrons depend on intensity but not on the frequency of incident radiation. As long as incident frequency was larger than the threshold frequency V0, that is nu 0, and the potential of anode was higher than that of cathode. So photocurrent is depend on number of electrons which are emitted from emitter. That is, it depends on the intensity but not on the frequency. That is, for ejection of electron you require some particular frequency, that is threshold frequency. Below threshold frequency there will not be any emission of electron from metal plate or emitter, but intensity is necessary for photocurrent. If number of electrons are more, then current is more. So the incident frequency was larger than the threshold frequency and the potential of anode was higher than that of the cathode. Okay, so this is all about observations from experiments on photoelectric effect. Now in next lecture we will discuss about failure of wave theory to explain the observations from experiments on photoelectric effect and Einstein's postulates of quantization of energy and photoelectric equation. Okay, thank you.